Okay, so I ran out of battery there. So let me try again. So once you've got the blood, so remember, you're putting the blood back in the fridge each time and bringing it out, okay? The rest of the solutions, you can dump whatever they didn't use or dump it back into the main solutions, or don't dump it back into the main solutions. Get the main solutions, the starch and the sugar, out of the fridge. So TAs, you'll want to, when you come in while they're taking the quiz or whatever, be filling everybody's solutions. And then the blood needs to stay in the fridge. Okay, so with the blood, they're just going to take their whatever salt solution, they're going to stick it into their container, and then they're going to pour blood into the container to the 2 centimeter mark. They're just going to follow the directions here. Again, anything that touches the blood needs to go in the biohazard waste. So if you notice tube 1, they're using 0.9% sodium chloride, that's isotonic. Now you're not going to tell them that, they'll discover it. Tube 2, they're using 10%, so that's going to be hypertonic. And tube 3, sorry, I wrote this while the batteries were dead. Tube 3 is going to be, you're going to put the 0.9 in, and then you're going to add 10 drops of tap water, so it'll end up being less than 0.9%, so it'll be hypotonic. So in tube 1, now they're going to be using the microscopes here, and we haven't used microscopes yet, so you actually need to train them on the microscopes before you start this lab. I'll do a little training on the microscopes in just a minute if I have time. But anyway, so they're going to look at them under the microscope. Keep in mind, they're not going to see anything until the 40x. So they're going to start at the 5, focus, go to the 10, focus, then go to the 40 and focus. And even then, they're really small. So if students are having a hard time, or even if you're having a hard time, a really good trick is to focus on the cover slip. So if you focus on the edge of the cover slip, it's a lot easier to find that than it is to find the blood cells, and then you can easily find the blood cells. So that's just a little tip of the trade. So in tube 3, when you do hypotonic, they're probably not going to see anything at all because it pops too quickly. But there's a really cool trick. If you're really good at microscopes, and you can have your students try this, you take the slide, right, and you have your little blood here, okay, and then you have a cover slip over top. Then what you can do is actually take water. So take your isotonic one, not the hypotonic one, but the isotonic one where you saw blood cells, and drop droplets of water right here next to the cover slip. So they're touching the cover slip. And then you can take a paper towel and lean it up against the other side, and it will actually wick the water through. So you can have one person in the group doing this while the other person is watching, and if they're lucky, they'll see the blood cells actually pop. It's really hard to do with the blood cells, but the elodia, you can totally see them shrink and grow. It's really neat if you do it this way. Okay, so that brings us actually to activity 4. I'm going to check and make sure this is still filming. Okay, it is. So activity 4, we're using plant cells. So they're going to use elodia. So if the lab tech, will you just place out a beaker of water with like maybe 3 or 4 sprigs of the elodia? That's all we need for this lab. Because each group only needs 1 leaf, not a whole sprig. If we let students use a whole sprig and they're throwing them away, we won't have enough for photosynthesis. So just 1 leaf. So they're going to take their 1 leaf, which I have somewhere, my little leaf. I accidentally put potassium permanganate in this water. So they're going to take 1 leaf, just a single elodia leaf, and they're going to place it on the slide. And they're going to cover it with a cover slip. I'll show you this. Now, if it's really dry, it will sometimes have a hard time sealing, so you can just take a little drop of water and put it on there so it'll seal better. Okay, I'm going to come show this to you. Okay, so you see my slide? Whoa, can you see that focused? All right, so I've just put an elodia leaf on, and I've smushed it with a cover slip. Okay, and they're going to take a look under there. This is a lot easier to find, and what they'll see is these boxy-looking leaf cells, like this, and then they'll see all these green blobs, and those are the chloroplasts. So they'll see those all over. It's really cool. And so they're looking at the slides, and it's in an isotonic situation. And then what they're going to do is add salt. So you're going to do it the same way as we did this. You're going to drop water on one side, and then use the paper, or not drop water, you're going to drop 10% salt solution on one side. Use the paper towel and wick it this way, and you'll actually watch, they'll plasmolyze. So the cell will actually, the cell membrane So that's the cell wall that I've drawn. Here's the cell membrane around like this. The cell membrane will actually pull away from the cell, and it will look like this. And all of the green, where did I put the green? All of the green will be clumped in the middle. Okay? You won't really see the cell membrane, it's sort of see-through, but the green will just clump to the middle. And then, what's even cooler, is you can put plain water on there and wick it back through, and they'll blow back up. It's really fun. Okay? So have the students mess with that. It's pretty cool. And they're going to draw it on the paper. Okay, so activity 5 is the potato wedges. At this point, they should be done. They're going to pull their potato strips out. And what I would do is say, what happened there? And most of this, you're not having any discussions on the board, right? You're walking around and having discussions with the table and asking them, what did you notice? Why did it look like this? Why did it clump? What are you seeing? With the potato wedges, you might stop and say, hey, everybody, pull your potato wedges out and let's look at them. And you'll notice that the one in the plain water snaps. It's like really rigid. And the one in the salty water is going to be all mushy, okay? And then you're going to ask them, why? Explain it in terms of what we've already seen here. What are you seeing? And this is a good place to make sure you've emphasized. You should have emphasized already with the red blood cells and everything, the tonicities, all right? So I like to draw 3 beakers. And you can do this with the blood cells. If you have the 3 beakers and our 3 blood cells, okay, and one of them might have looked really puffy. One of them might have looked nice and normal with a little dent in it, and one of them looked sort of like this. Okay? And so this one was in the 0.9 plus water. This one was in the 0.9, and this one was in the 10%. Okay? And so we want to illustrate what happened. Why did these guys pop? Well, because there was like this much dissolved stuff. Now there's a word for dissolved stuff. It's called solute. That is dissolved stuff. Okay, there's about that much solute inside the blood cell. Well, in this condition, the solute concentration outside was way low. And another word for dissolved stuff is tone. So this solution is not enough, hypotone. Hypotonic, not enough. And so, and please tell students that when we use these terms, hypotonic, isotonic, we are referring to the solution around the cells, not the solution in the cells, solution around. So this is not enough tone, and in that case, in order to be equal, water is going to try to enter to make that bigger and dissolve and diffuse out that solute. In this one, the solute concentration in the cell is about the same as the solute concentration out of the cell. Okay, so that's the same, or isotone. All right, and in this case, water is moving, but it's moving in and out at the same speed. Okay, and then the last one, the inside might have this kind of stuff, but the outside looks like this. It has too much, or hypertone, hypertonic. And in that case, in order to make the inside just as concentrated as the outside, we got to shrink the amount of space in there. And so in that case, water is leaving. Okay? So that's the discussion you want to have with students once we finish this. And the same thing with the potato is happening. Okay? Let me make sure the camera's still going. I don't want to do this again. Okay, so that's activity 5. Activity 6 is cheek cells. So this is just helping them practice looking at cells. So for the cheek cells, they're going to take a toothpick and they're just going to rub it on the inside of their cheek. They should see sort of mush. Don't tell them to don't destroy your cheek. And then you just take it and roll it onto a slide. And you can see it roll onto there. Okay? And then it says for them to dye it with methylene blue. That is different than Benedict's. Benedict's is this color. Methylene blue is this. It's very dark blue and it's in a crappy bottle. There's only 3 of them, so you're going to share. The methylene blue also comes out in giant drops. It will dye any DNA, so it's going to dye the nuclei of the cells. So I would recommend that they drop it onto just a piece of paper. Paper's not going to work. Like another microscope slide, and then just with their little sucker thing, suck up a tinier drop, because it makes a big mess. Drop it onto the cheek cells, put a cover slip on, always put a cover slip on, and then you can try to find the cells. Again, remind the students if they're having a hard time finding the cells, focus on the edge of the cover slip, and then go find the cells. And they're pretty big, you'll be able to see them. And that's the cheek cells. And then the last one is pond water. I'm gonna go get some new pond water, but here's the pond water. It'll look a lot like this, just and they're just gonna get to play. So they can grab slides, suck out some solution, suck out a leaf, look at it, and there will be all kinds of things swimming around. If they have a hard time finding stuff in the pond water, have them pull water out of the elodia. There are leeches, there are all kinds of stuff in the elodia, okay? So make sure they wash their hands after they do this. And so they're just looking for pond water, or looking for critters in the pond water. And that's the last activity. Okay, so the only thing I need to do now is the microscope training, so I'll do that right now.